Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And we're in the throes of the autumn here.
Yes.
And probably almost winter by the time this comes out. We are really ahead with our shows.
We're a little bit ahead, no question. But, it was that big block in November that we're going to be traveling in Eastern Europe. But it's like, I don't like being on the road when we don't have all the shows in the can.
Yeah, right.
For that week. I know we're going to pick up some while we're traveling, but we need to rely on those so we can still get back and record otherwise. Because stuff happens, That's reality. So I don't want to miss a show. That's what I don't want to leave anybody holding.
Right. So we recorded this about a month ago, and we're just going to have to pretend that all those great things in November already happened.
Including an election in the U.S.
Yeah.
So
who knows how that went?
Yeah,
I know. I voted.
Yeah. Well, I didn't because I'm a Canadian, and if I did, that would be breaking the law.
All right. Well, anyway, let's start with Better Know Framework. Roll the music.
Awesome. All right, dude, what do you got?
I have something that's very cool, yet I don't know how to pronounce it.
Excellent.
It's spelled OMI, and it's a next-generation web framework in 4K of JavaScript.
What?
It's a little bit different, right? I'm thinking it's oh my, but it could be Omi or Omi or whatever. I don't know. But anyway, it's trending right now. Everybody thinks it's really hot, and here's what I can read from the GitHub repository. So it merges JSX, web components, proxy, store, and path updating. It's only 4K gzipped. It supports TypeScript, has reactive data binding. It's based on Shadow DOM. It's easy to debug with OMI DevTools extension, which you can install from the Chrome Web Store.
Nice.
Has compliance with browser trend and API design. Merges web components and JSX into one framework. And it has a built-in observable feature, so there's no need to call this.update. And then, of course, there's a bunch of other features which you can go check out. We have the link to it because this is show 1603. You can go to 1603.pwop.me because if you Google OMI, you might get a bunch of stuff. But it's github.com/Tencent, TENCENT/OMI.
And you know who Tencent are?
Tell me.
This is the Chinese company that sort of builds a bunch of internet technology. They're sort of rivals to Alibaba, like they're those guys. So, and apparently they were one of the companies in the bidding for GitHub back in the day.
No kidding.
Yeah.
Well, they know how to get stuff down to a small container, don't they?
But I just find it interesting that we're seeing more and more. All of these internet savvy companies have libraries they're putting out in open source. Probably, hopefully, they depend on them themselves.
Yeah.
And so we all get to benefit from their work.
Still probably not small enough for Chris Love, however.
Well, you know Chris Love.
Yeah.
There's nothing small enough.
We don't need no stinking libraries.
Yeah. So their big claim to fame product is a thing called QQ, which is their instant messaging product.
Okay.
China has all their own orthogonal.
Oh yeah, I know.
Projects like the Beidus and so forth. Well, these are the guys behind QQ.
And they're in way more use than ours, aren't they?
Well, see, I don't know if that's necessarily true. It's at least often it's just China and is as big,
right,
as the rest of the world,
right.
You get that sort of effect.
Yeah,
yeah. I know what you mean. Oh, here it is. I'm just looking it up. It's like 700 million active users. Like holy man.
Well, anyway, that's what I got. Who's talking to us today, Richard?
Grabbed a comment off of show 1542, which we did with Mark Seaman, a compatriot of Stevens. That was the Constraints Liberate show from May of 2018. And great conversation as always. And Mark always dives in, any show you want to engage on, it's a Mark Seaman show. He's just one of those great thinkers. And this comes from Emma Ramelapaya, and I hope I pronounced your name correctly, sir. He says, I enjoyed the discussion and thank you to Mark and the folks at .NET Rocks. My thinking around this topic, this Constraints Liberate thing, is that if you substitute the word constrain with control, everything becomes easier to understand. I thought this was very insightful.
Yeah, that's right. It's from the opposite side.
Mm-hmm.
The constraint is something that's put on you. Control is something you have.
Right. And either way, they represent a form of control, right? The idea that he goes on to say cooking ingredients constraints are in fact a control imposed by nature or the person or anyone else that's the chef. And so they control the type of food that they produce. The Greeks put constraints on the writing of their mythology so that they control the types of stories that were being told. If we think in terms of controls, we can say that coding design patterns is a way to control the way programmers code to be certain that a certain kind of results are achieved.
Yeah.
Same in garbage collection.
Yeah.
I have always said that Microsoft achieved such a proficiency that is hard to beat. And to guarantee such a proficiency, you have to exercise control on garbage collection.
Right.
And so on. I just thought it was very insightful that, we are trying to build these, I hesitate to say walls, but at least gates and fences around our work so that we just have fewer problems. You stay within the lines here, and then you don't have to worry about the consequences of going over those lines.
Agreed. Well put.
So, Emma, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or via any of our social media. Well, these days we're only posting to Facebook. But if you comment on a show on Facebook, because we put every show there and we read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. And send us a tweet. Only 9 cents per tweet. Only 9. See, that's how we do it in America. We undercut. 9 cents. All right, never mind.
Yeah.
Let's bring on our guest, who assured me that I could butcher his pronouncement name with the Americanization of it, Steven van Deursen. He's a Dutch freelance .NET developer and architect with experience in the field since 2002, pretty much the beginning of .NET.
Nice.
He lives in Nijmegen and enjoys writing code for fun and profit. He's the developer of SimpleInjector, a moderately popular, his words not mine, DI container library for .NET. Besides writing code, Steven trains in martial arts, likes to go out for food, and certainly fancies a good whiskey. A brother among us.
Oh, no, I don't care for the whiskey. Impairs my judgment.
Yeah, we don't drink that whiskey stuff.
That stuff's bad for you, man.
Yeah. Before we start, I was in Houston for a low-carb conference, and some nutritionist or a dietitian, I guess, got up to talk about detoxifying. And it was hard to take. But anyway, I posted a thing on Facebook, and somebody replied, "Entoxifying is much more fun."
Well, we've certainly had more practice at that now, haven't we?
Well, anyway, welcome, Steven.
Thanks for having me.
Yeah. It's going to be one of those days.
Yep.
Yeah.
If you can't have fun with this, what more do you want, right?
Got to be able to have fun with dependency injection anyway. I mean,
sure.
The thing that's great about DI is that you just want it and it works, and that's it, right? You basically say, this is what I want here, and it just shows up when everything works right.
Yeah, and it's basically as well about constraints and control.
Mm-hmm.
So at one point you put constraints in your code because you want to, for instance, have all dependencies injected through the constructor. That seems a constraint.
Yeah.
But at the same time, it gives you a lot of control as developer because we move construction of our classes to the startup path of the application. Or we let the DI container do that for us. And that gives us a lot of control, more control than we would otherwise have. So to refer back to the discussion with Mark Seaman, it's all about constraints and control.
Yeah, it sure is. And if you've never used a dependency injection container, you probably haven't worked on a bigger project where you're just constantly newing up APIs or, web APIs or pages or all of these things where, I need one of those, I need one of those, I need one of those. And now you have to go back and deal with how you get those things into your constructor. Whereas when it's all set up right, it's just a declaration and then they just show up. It's wonderful.
Exactly. I do have to say that Mark and I, especially Mark, but me as well, started to appreciate working without a DI container. So practicing dependency injection, but not using a tool. And we do this actually more and more. And there's a lot of value in it as long as you practice the patterns and principles that lie behind dependency injection and software design in general. So still, for me, for big projects, I don't want to live without a DI container, but perhaps I'm a bit influenced as maintainer of SimpleInjector.
Right.
But that's something that many developers forget or actually don't know when they talk about dependency injection. They are referring to their tooling.
Yeah.
Instead of, I'm practicing the patterns.
Yeah.
I'm using constructor injection. And the tooling is useful, but optional.
Right. I mean, this is more about the pattern than it is about the tool. Because, I mean, one of the things I run into all the time with dependency injection is like, how many dependency injection frameworks do we need, right?
One more.
AutoFac. Yeah, the correct number is more. If only we had one that would bring them all together, right? And then we have one more.
Right.
Pretty sure there's an XKCD cartoon about exactly that.
Yeah. And Microsoft actually tried that with .NET Core by defining an abstraction over DI containers that the DI container maintainers could build, or they could build an adapter for that abstraction. But that proved to be a little bit problematic.
Did anybody use it?
Depending on what you mean the built-in DI container?
Yes.
I think that most AutoFac users that build ASP.NET Core applications are using their adapter for AutoFac.
Okay.
Mm-hmm.
So it benefited AutoFac, but did it benefit what a Castle Windsor, Ninjact? Like, I'm just trying to think of all the different ways we do DI in .NET.
Unity, Structure Map, Light-Inject, SimpleInjector.
Did anybody else implement against it?
Yes, the Structure Map guys have an adapter. I think Castle Windsor has one. Unity, I think, has one. SimpleInjector doesn't have one. We didn't even try. and that's me, because there lies the whole problem with the abstraction that Microsoft defined. They tried to define the least common denominator so that all DI containers could implement an adapter. But in the end, the whole DI container maintainer community, so the developers behind AutoFac and Structure Map and Castle Windsor and me, myself, we all get very frustrated by the whole process and what Microsoft ended up with. Mm-hmm. So the example that I always give to people is, well, Microsoft tried in their abstraction and their DI container to mimic the behavior of AutoFac, but even the AutoFac adapter isn't 100% compatible with the abstraction.
Interesting.
Huh.
And not only AutoFac, because the Structure Map adapter isn't 100% compatible, and I know for a fact that the Unity adapter isn't 100% compatible. And the problem is that it's actually impossible to have a 100% compatible adapter, or if you could have, you're locked in to the abstraction that Microsoft gives you, and that limits your possibilities as a library maintainer. And that was one of the reasons that I and the other developers behind SimpleInjector said, okay, this is not a path we want to walk. And actually, we couldn't even, because the incompatibilities between SimpleInjector and that abstraction that Microsoft defined are huge. So they were unbridgeable. And we could only bridge those gaps by stripping features from SimpleInjector and changing behavior of SimpleInjector.
How do you think that happened? I mean, how do you think they came up with something that was just incompatible?
That's a good question. Well, what happened was that Microsoft was unhappy with how things work in ASP.NET MVC and Web API.
Yeah. While
they have their configuration system, it's quite limited. So Microsoft wanted a few things. First of all, they wanted, let's call it a composition system, where they could compose their own components. So the components that ASP.NET Core needs, and there are dozens of them, of course, they wanted to have a system where they could easily compose those object graphs. Well, and a DI container is an obvious choice. So that was one thing they want. And the other thing they wanted to achieve or prevent is what I think David Fowler called the endless permutation of libraries.
Yeah.
So, for instance, every time Microsoft comes up with a new framework or frameworks that are built on .NET Core or built on ASP.NET Core, they have their own abstractions. And so each DI container must have an integration package.
Yeah.
Right.
That was the old model. So AutoVac had integration for MVC, had integration for Web API, had integration for SignalR, etc.
Mm-hmm.
StructureMap the same, SimpleInjector the same. And so they wanted to end that endless number of packages that everybody had to create and maintain. So that was the idea. So therefore they cooked up an abstraction. The problem is this, that DI containers are so incompatible with each other when it comes to their registration API that it's impossible to define an API that works for everybody. And well, AutoVac again is in behavior quite close to the original abstraction because that was what Microsoft used to
test with, I imagine.
Yeah, I think that the designers were using AutoVac internally.
Right.
And were experienced with AutoVac, and that's how they built their own container. And based on their own implementation, they created an abstraction.
Yeah, okay.
Yeah, natural bias then.
Yeah. And so the implementation details are also leaking into the abstraction.
Sure. It's very challenging to build a abstraction like that. Once you understand enough DI containers, you pretty much figure out there's just no commonality.
Exactly.
Right.
Or at least there is some commonality, but it's just too little to build a least common denominator.
It becomes a non-thing, right? Like it doesn't actually do anything for you then.
Yeah. So what works as an abstraction is something that resolves. And that's what we had in MVC and Web API, the Dependency resolver. It was an interface with one method, get service or get instance. I'm not sure what it was.
Right.
But that's pretty safe because that's just asking the container, oh, I assume you have a valid configuration. Give me an instance, which is completely the opposite of specifying what you want to register, because then you get into order of registrations, how to build up decorators, how to register them, how to handle collections, how to handle fallback scenarios, how to handle generic typing. And those are all the areas that you see that the abstraction fails in, because it simply isn't something you can abstract.
Right.
And there is where things went unfortunately wrong, and that's why a lot of the maintainers were quite frustrated.
And Steven, I'm going to interrupt you for just a moment for this very important message.
Hey, Carl here. If you enjoy music to code by, you or someone you know might be interested in the app, which I've generically branded Music to Flow by. See what I did there? It's a subscription model. And if you bought the complete collection of Music to Code by before October 24th, 2017, you are eligible to win a free 6-month subscription. With that, you get access to all the tracks on your phone with offline support. You get continuous play and even a sleep timer. Download Music to Flow by in your app store and flow on.
And we're back. It's Richard Campbell here with Carl Franklin. We're talking on .NET Rocks to Steven van Deursen. Is that right?
Yeah, sounds right.
Okay. Got more or less there, admittedly, an anglicized interpretation of it. Dutch is always more challenging.
Yeah.
And I'm really glad we're sort of getting back to dependency injection, because I think it's one of those things that a lot of us take for granted and a non-trivial number are still just never used or ever been involved in.
Yeah. How does the saying go? It's like... It's like reproduction. If you've never done it, you don't know what you miss.
Right.
Okay. I like it. And I totally agree.
Yeah. It's one of those things that once you're in there, it's impressive what it does for you. Just separating concerns.
Absolutely. And in the end, it constantly comes back to software design and the software design principles. And I see developers struggle on a daily basis with dependency injection, or at least that's their complaint. I've got problems with dependency injection. And when you start looking at their code, it's typically not dependency injection that is the issue, because in theory, it's pretty obvious. Just inject your dependencies through the constructor. That would be basically it. And everything else is design. And that's what I personally love about dependency injection. When your design is incorrect, or let's say a bit suboptimal, with dependency injection, you'll typically find out sooner.
Right.
And that's what I really like about dependency injection, because now people start complaining. For instance, one of the main things that will trouble developers when they start with dependency injection is that their constructors become very large. And because their constructors have 12 dependencies, 14, and it keeps on growing.
Right.
And they say, yuck, dependency injection isn't working.
Right.
Well, I think I think it's working fine. Perhaps. Well, you fill it in.
Yeah.
Yeah.
And yeah, obviously the problem here is code smell we call constructor over injection.
Yeah.
And that's typically caused by a single responsibility principle violation. So the class just is too big or does too much, has too many responsibilities. And if you fix that, and there are many ways to refactor a class that's doing too much. But if you do that effectively, you will see that the problem of constructor injection goes away.
Right.
So again, that's one of the things I love about dependency injection. It makes it more clear that there is a problem.
Yeah. What Scott used to say is, I want you to fall into the pit of success.
Yeah.
So like if you're struggling with this tool, it's because you're going down a path that's going to impair you, and your life will actually be easier if you can work with this tool. Dependency injection tends to create more maintainable code.
Mm-hmm.
Yeah, exactly.
Sure does.
That's very fair. I think I like that. So why'd you make your own? What's wrong with Autofact?
I was missing certain features, I think. Well, first of all, I started dependency injection library projector, the predecessor of SimpleInjector, actually just to try to understand the principles behind it and how to work with dependency injection. And at some point, I started to look at other DI containers, and I thought, this is too complicated. I will continue. That's, I think, the trap that's why we probably have so many DI containers in the .NET ecosystem. So in the end, the pattern is simple, but writing such tool comes with a fair amount of complexity.
Yep.
But once it started to grow and it started to gain traction, so more users came aboard and feature requests came in, then it started to get a life of its own. And I more and more was looking at how do other DI containers implement this.
Mm-hmm.
And sometimes, not always, but sometimes I just was in disagreement with their approach. And so that ended up with SimpleInjector. And if you compare all DI containers, I think that SimpleInjector is
simple.
Well, that's the goal, but it differs the most from the others. And that's why, for instance, with if we come back to the .NET Core adapter, DI adapter problems, that's why most DI containers actually choose to have an adapter, because they would be reasonable compatible. While for SimpleInjector, it just didn't work. There were just too many things that we are doing differently, and differently for a very specific reason.
Mm-hmm.
Because I myself, as user of DI containers and working in larger teams that use DI containers, I see people trip over the same mistakes again and again.
Mm-hmm.
And so that was what I and the people who later came aboard and loved the project tried to fight. And we tried to design the API in such a way that we would limit the amount of problems that you would run into.
So it's the whole constraints thing, isn't it?
It absolutely. So, and for instance, at the basic level, there are a few use cases that SimpleInjector just doesn't implement out of the box. For instance, property injection is not enabled by default. While, for instance, Castle Windsor has property injection enabled by default. And I figured that actually isn't a good way to do dependency injection at all.
Mm-hmm.
So perhaps in some corner case you need property injection, but by default you don't want to do it. So it's not included. The same holds for support for handling components with multiple constructors. Why do you need multiple constructors? That's ambiguity.
Mm-hmm.
You want one public constructor that contains dependencies.
Well, Steven, I'd like to ask you to hold that thought right there because guess what time it is, Richard?
It must be that happy time again.
Yes, it's time to provide some rich separation of concerns for this show by injecting the middleware with a related joke. Fortunately, there's only one reference, and it's null. Sorry. Sorry. Another one bites the dust.
Not a great constructor.
Nah. Actually, it's time to give away a $200 Amazon gift card, compliments of Progress Telerik, to one lucky member of the .NET Rocks fan club. But first, let me tell you about the most comprehensive developer toolkit for building modern apps on the market today, Telerik DevCraft. With more than 1,100 Telerik.NET and Kendo UI JavaScript components and controls, you can easily build modern, high-performant web, mobile, and desktop apps, as well as chatbots. The toolset also includes reporting solutions, automated testing, and productivity tools, and comes with a range of support options. And new this year is a free online training program for all license holders. With this, alongside thousands of demos with source code, comprehensive documentation, and a full assortment of Visual Studio templates, you'll be up and running with the Progress Telerik and Kendo UI tools in no time. Download a free 30-day trial today at telerik.com/download, and also consider supporting .NET Rocks by making a monthly pledge at patreon.netrocks.com.
Well, all right, buddy. Who's our winner?
Today's winner is James Holton.
Congratulations, James. Golf clap for you.
Golf clap for James. And James just won a $200 Amazon gift card just for being a member of the .NET Rocks fan club, compliments of Progress Telerik. And if you'd like to join the fan club, go to .netrocks.com, click on the big Get Free Stuff button, answer a few questions, and join up. We have thousands of members all over the world. In every show, we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree. Coming right up here, isn't it?
Mm-hmm.
Not today. To one lucky member of the .NET Rocks fan club. But you got to sign up to win. And of course, Steven, we like to ask our guests, if you had $5,000 to spend on technology today, what would you buy?
Ooh, well, 5,000 is a lot, and I'm not that much of a gadget guy, but I'm very much interested into security, web security. So a Hack 5 Pineapple.
Oh, nice.
I know. I haven't looked at one of those in ages.
Yeah, me either.
You can cause a lot of trouble with a pineapple. My goodness.
So if you've ever heard a show we've done with Troy Hunt, a pineapple is this little device that looks like a Wi-Fi access point, but it really steals your passwords. You just walk through the airport and pick them up.
Yeah, it's an awesome device.
Yeah.
Only for good, of course.
Only for good.
Well, yeah, or at least to amuse yourself to some degree. Oh, look,
Yeah,
they made a new unit, the Tetra. Ooh, fancy. $200.
I find it's really good for scaring customers into getting serious about security.
Just firing it up in a Starbucks, and you find out how many people have a Wi-Fi access point at home with the default name, default passwords, and it's just like you just walk through them all. Boom, you're all attached to them. It's crazy how well that works.
Yep.
Yeah, for $5,000, you can get a lot of pineapple, man.
All right, we were talking about some of the other constraints of SimpleInjector.
Yeah, so I think the differences between SimpleInjector and the other containers is basically in 3 areas. So at one hand, we just decided to not include certain features or not enable them by default to push developers into a certain direction that we or I think are beneficial. Second is that we try to design the API of SimpleInjector in such that we push you into what we like to call the pit of success.
Right.
And the last part is the verification feature that makes SimpleInjector, in my opinion, pretty unique. While other containers sometimes have a verify option that tries to create all the register objects, SimpleInjector goes one step further and analyzes that object graph. So even if it is able to construct a graph of objects for you, it can still detect common problems. For instance, captive dependencies where you inject a scoped, so a short-lived object into a longer-lived object. And there are other common pitfalls that the verification feature of SimpleInjector checks on. To my knowledge, that still makes SimpleInjector pretty unique.
Yeah, it sure does. So what does it look like in practice? How do we get started with this thing?
SimpleInjector is, like all DI containers, can be found on NuGet. We have the simpleinjector.org as a homepage, and that will lead you to either GitHub or our documentation. And it's pretty much like any other DI container. So you pull it in through NuGet, start registering stuff. There are a few standard templates that you can use for MVC and Web API. For ASP.NET Core, just go to the documentation and you'll see how to integrate SimpleInjector into ASP.NET Core. And note that is even possible even without having an adapter. So it makes things a little bit different, especially if you're accustomed to the Microsoft documentation that pushes you into the direction of adapter implementations of their DI container. So you will have to look it up, but you'll notice right away that it isn't that complicated with SimpleInjector or even that much different. And from a high level perspective, SimpleInjector's API isn't that different than you're used to with other DI containers. We've got register methods that do half of the work.
Yeah. So it's all code, I presume. There isn't any Visual Studio integration necessary for this, just like other containers?
Exactly. Although we did some work on debugger views in the past, only they broke with Visual Studio 2015. And I'm not sure if Microsoft fixed those problems. Because what you can do with SimpleInjector, not only do you have the verify option, but once you've done that, in the debugger, you can hover over the container instance.
Okay. Then
you get a debugger view that shows you not only which registrations you have, but also which of those are root objects, so the top of your object graph. You can drill in and visualize them in a C# text-like manner, like if you knew everything up by hand. So it gives you the overview that you would have had if you were doing dependency injection by hand. And that can be a very, very useful feature. And especially if the container is complaining that a dependency missing, where you can just drill down and look into the container, what dependencies do I have? And that's very useful. But you don't need extra packages for that. That's just in the core DLL included. So if you use Visual Studio, that should pretty much work out of the box.
Awesome. How do you pick a DI container? Anybody who's listening to this and hasn't selected one yet, I mean, because there is an array of them. And I know you're going to be biased because you love yours, but I'm just trying to see what makes someone choose one over another.
In the end, it's, I think, a little bit taste. But first of all, what I nowadays usually advise is to start without a DI container. So that's the practice that Mark Seaman calls pure DI. So in other words, we knew everything by hand, but we do that still at the same location where we would have been using a DI container. So the startup path of the application. That still leaves the rest of the application completely clean and completely decoupled or loosely coupled. And when the application grows and you start to experience that startup path of your application, we call it the composition root, that it is starting to get less maintainable, that could be the time that you should be looking for a DI container.
As soon as you feel like you want to build a DI container?
Never do that. Never build your own, except if you are building it, for instance, like Autofx, Structure Map, SimpleInjector. They are built to be used by thousands of developers, and me and the other maintainers are focusing on keeping it running. So if you are building your own DI container for your own company, please don't.
Yeah.
Absolutely don't. And that's what a lot of developers think that Mark and I are saying. If we say don't use a DI container, they ask, so I should build my own? No, you shouldn't use reflection at all. So really just new everything up. And there is some sort of myth that the new keyword is illegal to use. That's not the case. Only we want to prevent newing up our components within our application code. So rather we wanted to have it in the infrastructure, in that startup path of the application. That's the place that we want to new up our components or use a DI container.
Right.
And it depends a bit on the features you require and the size of the application you have. So it's really hard for me to say what requirements should you check. So obviously I'm biased towards SimpleInjector because I think it guides you the most into the happy path, but have had quite some heavy discussions with developers who weren't pleased with the pushing that SimpleInjector does, because they say, well, but I want to go another direction because I feel that is the best direction, and now SimpleInjector is in the way. But that's true for any DI container that you will use. So you will have to pick the container that suits you the most. But that's actually a quite hard thing to do, because the time that you're looking for a DI container, that's probably a moment that you don't really know yet exactly what you need. For instance, with SimpleInjector, some developers are struggling when they start with SimpleInjector, especially if they switch from another DI container, because some things are just very different in SimpleInjector. But then when they start using the verify functionality, a new world opens for them, because now the container suddenly says, well, that set of registrations that you have here, that might not be as safe. And then they say, oh, that's why we sometimes had problems in production with caching and weird exceptions. Well, that might be a captive dependency problem. So it's hard to know what you need unless you have thoroughly experimented with it. So that's, I think, the only thing I can advise people: try multiple frameworks out. Look at what their vision is, what they're trying to achieve, what kind of features do they have, if you can plug in new features or change behaviors easily enough. And that would be your starting point, I think.
I like your pattern of you start writing as if without a DI container, and then you get to a point where you're like, okay, I need some tooling around this.
Yeah.
It feels like you almost have to take a day and experiment with a few different libraries to see one that makes you comfortable.
Yeah.
So if you have a web app versus a Windows app versus a mobile app, are different containers or types of containers or injection libraries more suitable for those different application types? Or is it truly a one-size-fits-all kind of thing?
Yes and no. I would say that most DI containers that I'm aware of run on all kinds of platforms. So
yeah,
some even run on Windows Phone. but I think nobody's doing that.
What? Windows what?
Windows what?
Huh?
Yeah, exactly.
Who?
Or Silverlight. Who?
What? Where? What is this thing you speak of? Yeah.
I understand the words you're saying. I just don't know that they mean anything to me.
Exactly.
Yeah.
But some containers are useful for different kind of application designs. For instance, if your application is starting to grow, it becomes useful to use what we call auto-registration or assembly scanning. So the container will look for all the types, and you specify a pattern of which types to register and how. For instance, the built-in DI container of .NET Core doesn't have this scanning ability, and it lacks all kinds of other features as well, such as being able to register decorators. And it's actually quite difficult to build that on top of it. So for certain application designs, you want a different container. And for instance, the thing that SimpleInjector focuses on is generic typing. It has been very good for a long time to handle all kinds of generic types. And that's based on my own experience, where I noticed that my application design shifted over the years into a design where, say, 95% of the components in my system implemented a single generic abstraction. So I would typically have a few generic abstractions, an abstraction that would handle command objects, an abstraction that would handle queries, abstraction that would be able to validate certain objects, and those are 3 generic abstractions. And then you can say, and typically it holds for a structure map and artifact as well, that you say, okay, this is the abstraction I have, look for all implementations and register them. And with SimpleInjector, it is very easy to register generic decorators on top of them. And not only that, but make those decorators have generic type constraints. So, for instance, the generic type constraint on the generic decorator would allow you to have only part of the components of your system be decorated with that decorator and have compile time support with it. And that's something that not many DI containers have. So, and that was just because my own design was going into that direction, that I saw the need for being able to have my DI container filter based on generic type constraints.
Yeah. So I take it that there aren't any other real cross-platform concerns?
As long as the platform complies with .NET standards, everything should work out of the box.
Mm-hmm.
I believe that there are always bugs in other platforms.
Yeah.
One thing I know from the past was when Silverlight was still a thing and SimpleInjector had Silverlight support, or well, it still kind of has, but nobody uses that.
Yeah.
When I started to run SimpleInjector in a Silverlight sandbox, everything broke. And especially when it came to internal types, because reflection is severely limited in Silverlight.
Oh, right.
And nowadays, Microsoft just advises you to run your .NET environment in full trust. So they don't even, for instance, for web applications, don't even support partial trust anymore. And Silverlight had some kind of extra limited version of partial trust. And in that case, when I started to run all the SimpleInjector tests in the Silverlight sandbox, a third of them failed because of reflection limitations and method calls that were missing. So a lot of work was done to not only ensure that it worked, but also that good error messages were communicated to the user in case he did something that the Silverlight sandbox didn't support. But in the newer environments, that should not be a problem, at least as long as there are no bugs. But typically, DI containers just use a very limited part of the .NET Standard API. So typically nothing that complex. So it should work. Fingers crossed.
Okay. And Is there anything that you want to admit might be difficult for people to, stumbling block or a feature that's not quite there yet or something that they need to tweak with in order to get it to work?
It depends on your needs. There are many features that other DI containers have that we just didn't want to include. So if you need them, typically in the documentation, workarounds are described or ways to handle it with SimpleInjector. A few years ago, a large deal of frustration came from Identity Framework, or at least the Visual Studio templates that were provided by Microsoft for working with Identity Framework did very weird things concerning dependency injection and design in general. And a lot of people stumble over that when they tried to plug in SimpleInjector. Yeah. And those questions still come up from time to time. And what sometimes is funny, I had conversations with developers. They said, well, but I tried it in Unity and it worked out of the box. And then you look at their configuration and then you say, well, I don't think this actually works. but you just don't know it yet. Yeah. Again, the compatibility with ASP.NET Core, people are still sometimes stumble over that. So yeah, there are enough features, but they're not really missing. Well, what we want to do in 4.5 is to allow collection of T and list of T types to be injected into the constructor. Currently, we only support I collection of T and I list of T. So not the concrete types. So that kind of features will be adding. Verification features will be added in the future. So still, sometimes I get asked the question, well, aren't the DI containers finished? What else is there to build? What kind of features do we still need?
Yeah.
But the funny thing is it actually never stops. Although I must admit, most of my time I spend with helping developers. I think writing code is less than 1% of my time when doing work for Simple or on SimpleInjector.
Whenever I see a market this fragmented, like there's so many successful products, it just says to me there isn't one right way, because there would be. We would have consolidated by now if that was the case.
Yeah, exactly.
Yeah, the fact that there is a diversity and it's not like one big one and a bunch of little ones. It's literally a diversity. It just says, there's no simple solution here.
Yeah. If you look at the download count in NuGet, you'll see that I think Unity is the biggest, Artifact number 2, Ninject, StructureMat, Castle Windsor, SimpleInjector. And I think the download count between Unity and SimpleInjector is a factor 5. Or something in that range. So the differences I agree, aren't that big. So there are a lot of different flavors, and sometimes it's just historical. People are used to working with Unity in a company, so you keep using Unity in a company. And if it works, why change it? Never change a winning formula.
Right.
And there must also be a good reason to switch, because even though I would love everybody to use SimpleInjector, there is a risk and there are costs in switching your libraries. And that's also one of the reasons that I advise people to start without a DI container if the application is small.
Yeah.
Because it's a dependency less. Dependency injection is all about dependency management, but we add the dependency on an external library.
Yeah.
Yeah, totally makes sense.
So what's next? What's next for you?
Well, for SimpleInjector, it's just the work continues. It's not that much, and currently we already talked about Mark Seaman, and Mark and I are finishing the second edition of his book on dependency injection.
Cool.
And I think Manning will publish it in December, I think.
Nice.
And so this is dependency injection in .NET.
Yeah, or at least the title of the first edition is Dependency Injection in .NET. The title of the second edition, okay, this is going to sound a bit weird. The title of the second edition is going to change. And I'm not sure yet if it's still called Dependency Injection in .NET second edition. Probably it will be called Dependency Injection second edition, Principles, Patterns, Practices.
Okay.
Because we had a lengthy discussion with Manning, and the fact that it says .NET on the title might scare people off, while the book is very much useful for instance, Java developers and other object-oriented languages. Perhaps even more dynamic languages, although I'm not very familiar with them. So only the examples that we give are in C#. But we try to be very conservative about the used C# language. So our goal was, and Mark's goal with the first edition already was to make the book applicable to a broad range of developers. And that's something we try to maintain in the second edition as well.
Very good. Well, this is awesome stuff. Wish you the best of luck with it.
Thank you very much.
And thanks for being with us today on .NET Rocks.
Thanks for having me.
All right, and we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a